That was just technical glitch. Let's continue with 5.3. 5.3 we said, according to this one, they say antacid tablet is 40% calcium carbonate. Therefore, another antacid tablet of mass 2 grams is allowed to react completely with HCl. Now we say, first and foremost, before you can calculate the volume of carbon dioxide, then let's find the mass of calcium carbonate in that antacid, which is 40%. This will be the case. Then from there now, you have to now calculate the number of moles of that mass. We know how to calculate the number of moles. Number of mole of calcium carbonate will be the same as given mass over the molar mass, which is 0.8 divided by 100. Then this will give us 0.008 mole, or you can have 8 by 10 to exponent minus 3 mole. No problem if your calculator is on scientific mode. Then from there now, remember, according to the balance equation here, if you look at the balance equation, 1 mole of calcium carbonate produces 1 mole of carbon dioxide. So they're in the ratio 1:1. We are using that one. Therefore, number of mole of carbon dioxide will be the same as number of mole of calcium carbonate, which is the same as 0.008 mole. Fine. Now we have got number of moles. We can find the volume. Therefore, we know how to find the volume from moles. Because we are at STP, we know that now we are going to use the volume of carbon dioxide will be the same as number of mole multiplied by the molar volume. Therefore, is 0.008 multiplied by 22.4. Therefore, the answer should give you 0.18 decimeter cube. That is the answer for 5 marks, which is 5.3. Very important in this case, we are finding carbon dioxide using calcium carbonate. So be careful there. The ratio, the mole ratio in the balance equation is very vital to use there. We move to the next questions for 8 marks. Now, this starts from 5.4. So the question here, according to the question paper, there we are given a graph here. They say the reaction rate of similar antacid tablets with excess HCl. And now HCl is excess is limiting of concentrate 0.1. So this in excess is not limiting. The antacid is limiting, yes, at different temperatures is measured. The graph below is obtained. You can see, remember, don't forget that 1/time is the reaction rate. So then we've got temperature against the rate, because in this section of reaction rates, remember, there's only one dependent variable, that's reaction rate, and then all the other factors will be independent variable. Use the information in the graph to answer the following questions. 5.4, write down one controlled variable for this investigation. Remember, there are 5 factors. Therefore, if you are going to investigate temperature with reaction rate, all other factors have to be kept constant. In this case, when you look at this, the one that is just immediate will be the concentration of HCl has to be kept constant in this case. Concentration, can just say concentration. If you want to be explicit, you can even say concentration of the acid, or just even be explicit and say HCl. It's also fine. In that case, the other factors that should be also be kept constant in this case will be, this is the first option, and the other one will be the state of division, the size or the mass of the tablet, or the type of tablet. In that case also can also be, the type can be accepted as well, type of tablet that you are using. And then the other one will be, okay, the state of division of that tablet. If you use powder, you must use powder in both cases. State of division for the surface area, in this case surface area. So fine in this case. Okay, fine. Now 5.5, they say to us, look at the question here. I have to read and check what is happening in this one. Now we have to write. Now they say write down the conclusion that can be made from the graph. We look at this graph because conclusion is always based on facts. According to the data collected here, you see now the temperature is increasing and also the reaction rate is increasing. Therefore, increase in temperature increases the reaction rate, or as the temperature increases, the reaction rate also increase, or reaction rate increase with an increase in temperature. Your English will just play a part there. Fine. Or we can even talk about the opposite now, but just to avoid many options, this is the perfect one. As the temperature increases, if you look at the graph, as the temperature is increasing, the reaction rate also increase, or increase in rate. Reaction rate increases with an increase in temperature. The next question say to us, use the collision theory to fully explain the answer in 5.5. Why an increase in temperature increases the reaction rate? We know collision theory. Remember, we've got 4 parts of collision theory that you must prepare for. We've got temperature, we've got catalyst. Normally we combine these together because they always talk about the more particles having enough kinetic energy. We've got concentration and the state of division or surface area. So also this one, they will be also grouped together if you are explaining, then because they will both, second point, they will be talking about the collision of particles with correct orientation. So this one talks about the enough kinetic energy of particles. This one is about collision of particles with correct orientation. Now we are in this group, therefore the first point will say, as we increase temperature, from the definition, increase in temperature increases the average kinetic energy of particles. That is 1 mark. The second mark, this is normally 4 marks, but anyway they're giving us 3 because they already say the radius increased. The second one, once the average kinetic energy of particles has increased, therefore more particles have enough kinetic energy. What is enough kinetic energy? We normally say this is the kinetic energy that is greater or equals to the activation energy. Or you can even just say the particles with enough kinetic energy increases. So fine, the number of particles with enough kinetic energy increases. If you don't want to say more, so the more is easier, more effective collision. That's the next point. More effective collisions. Remember, this will be qualified if you write the word per unit time or per second. So per unit time or per second, or even saying the frequency of effective collisions increases. Also that one will give you the mark. That's the 3 points. 5.7, which is the last one. They say to us, the last question is 5.7. They say redraw the graph in the answer book. On the same set of axes, sketch the curve that will be obtained if HCl of concentration 0.2. We are using 0.1. In other words, we are increasing the concentration. Is now used. Label that curve Y. Now let's redraw the curve. This is the original curve that we are having. This is the original one. Start from here and goes. Fine. This is 1 over time in per second. And this one it's a temperature in degrees Celsius. Fine. Now they say draw. Now will the graph be low or higher? Therefore it means that now the graph will be higher in this case, and this will be the case. That's all for this one. It shows that now when increased concentration, the rate will also increase. So make sure that the graph in all points, then the rate is higher. Thank you. Bye.